Okay, so welcome to lecture number 5. Uh, Today we will start with if statements. So the basic of the if statement is you give some condition and we will test that condition. If that condition is true, then a part of the code written inside curly bracket will get executed. For example, let me just check. Yeah. For example, if I want to check if number A is greater than number B. So what I will do to put it in a C program, I first put a bracket and write if around those bracket. And let's say if I want to say A is greater than B, I will put a curly bracket open close and then I can write printf, and in the curly round bracket, I will say A is bigger or whatever, and then semicolon. So this statement will only execute if A is greater than B, otherwise nothing will happen. So this is about the if statement. It's pretty easy, but it will solve most of your programming problems, because this is where we check for the conditions. Whether if condition is true, then we will go for the statement, otherwise we will not do anything. Now let's understand how this if statement works. So if statement evaluates the expression written inside the round brackets. If the test expression is evaluated is true, then statement inside the body of the if loop are executed. If the test statement evaluated is false, then statement inside the body of if loop are not executed. For example, this is where you write all the working statement. Here the exact expression int test equal to 5. If test is less than 10, then some working and then code after this if loop. And when the expression is false, like int test equal to 5, if test is greater than 10, then some line of code and then after that. So as soon as this condition fails, it will jump to the next block over here. Next thing is, let's try and see one example with if statement. Write a program to display if the number is negative. So whenever we want to see whether the number is positive or negative, we just have to compare with 0. So what this if statement is doing is, if number is less than 0, then printf you have entered percentage the number, and if it is uh, not less than 0, then this particular statement will not execute. So code goes something like this. Hash include stdir, that is library inclusion. We generally include 4 of them now. Then int main, then int number. Then we ask user to enter the number. So printf, enter an integer. Scanf, now it is entering only the integer. So that's why %d. Ampersand, because it's a scan, there should be an ampersand number. Then if number less than 0, printf you have entered %d, then slash line for new line, and then number. So printf, the if statement is easy and return 0. So there are two outputs with this particular case. If users enters -2, it will display you have entered -2, and if statement is easy, will be still printed. When user enters -2, the expression number less than 0 is true, and hence it will display that you have entered -2 onto the screen. The second kind of output with the same code, when user enters 5, then it is not less than 0, so it's a positive number. So if statement is easy, is only displayed. When user entered 5, the expression number less than 0 was false, and hence the statement inside if loops were not executed. So with that, you can write one program where you can determine all the positive and negative numbers. Okay, so we will do that in the programming section. Next is else loop. So if something goes wrong, then if you want to do something, okay, then if and else is like, if the statements inside if loop gets executed, then statement inside else loop will not get executed. It's like if this is true, then this is not true, and if this is true, this is not true. So if you have this kind of arrangement, then you have to use, along with if, you have to use else. Now remember, else is not required in C programming until and unless you have a conditional false or conditional true statements. Like if one of the statement is true, then the other statement cannot be true is the fact. So if I say I am male, then I am female statement becomes false. Similarly, there could be the coin tossed and it was fallen on the side heads. Then it was fallen on the side tails becomes a false. So it is like a binary decision. If this thing is true, then other thing is definitely not going to happen. And that's why you put all those statement inside the else loop. Now this is similar syntax, but for else you don't have to write again that condition. Like somebody will say, if I ask you to check whether the number is greater than 5, you have to only check if, like you have to write if the number, let's say a was the variable, is greater than 5. Okay, now don't write else a less than 5. That is not required. It was pretty much assumed. And here user can make a mistake. What will happen if a equal to 5? So all these conditions will falls under else. So if this is not true, then everything else will go into else loop. And that's why this kind of if else statement are used only when something you want to do if this condition is true, and something you want to do when this condition is false. There are many examples where we will require this loop, and it's like a heart of any programming. So every computer programmer must know this particular loop. It is the most commonly and most widely used loop everywhere in the programming, and it is one of the biggest or most important statement because it decides the logic. None of the other statements inside a program can decide a logic. It gives the ability to the computer to think, read what is the value, and then decide. So this statement is very, very important, and you should do multiple things once you learn the if statement in the C programming. Let's see another example how if else statement works. So if statement is evaluated true, then statement inside if statements are executed, while statement outside the body inside the else are skipped for the execution. And if statement is false, then statement inside the else are executed and statement inside the if body are skipped. Let's take an example over here. If test equal to 5, and if I say test is less than 10, then it will go inside this, execute these statements, and then come out and directly go beyond the statements of the else loop. Whereas let's assume another expression, int test equal to 5, and if test is greater than 10, then curly bracket, all the statements are skipped because test value was 5 and you are checking whether that value is greater than 10, and it will directly go to the else loop. It will execute this body of statements and then go to the next program. With the actual example, let's say whether the integer is odd or even. Okay, now this is again a binary decision. If I say my number is odd, then I am sure that my number is not even. Okay, it's like head and tail. It's a binary decision. So that is a good thing here. So what I will do is hash include stdio.h. We generally add 4 of them. Then int main, int number, printf, enter an integer. Then scanf %d ampersand. So you never forget ampersand whenever you are using scanning. This is a mistake student do. And another common mistake will forgetting the semicolon. Now this is a bad thing. 99% of the student will make one of these mistakes in their life, like forgetting a semicolon and forgetting a ampersand. And you might have done it already. If not, you will do it in the soon future. Hopefully that is not your exam. Next, let's go to the if statement. So what this person has done is if number percentage 2, okay, this modulo operator, now whenever it is divisible by 2 and equates to 0, then it is a even number. So this is the simple logic of even and odd. And this is the next program we are also going to write whether the entered number by the user is even and odd. Here you can do for a fun stuff, take a percentage f and enter 2.0001 and see what happens, whether it's a integer even or odd. Now here it is very specifically mentioned that if it is not even, then it is else. Now there are third cases in the binary decision which are very rare, like your coin cannot be head, cannot be tail. And in that case, actually it is only checking whether it is divisible by 2 or not, or it is might be checking whether it is head or not. And it else means everything else. So whether coin is standing or coin has fallen on tails, everything will go inside this condition. Similarly, if it is not even, that means it must be odd. That's it. There are nothing else considered. So that's why else loop doesn't have anything in the bracket. Then return 0 to end the program. The output for this program is user does enter 7 and it will display 7 is an odd integer. So this is the next code you need to do. When the user enters 7, expression number %2 will equate to 1. That means number equal to modulus 2 operation is not equal to 0. So this will remain as false, and hence statement inside else loop will get executed. Now, how to create a ladder? So, if else is one of the method to create a ladder of expressions. Now, if there are multiple outputs, like you don't have only two outputs. For example, you are playing a dice, and dice will have 6 outcomes. So then how you will do it? So you will go into the loops one after another. For example, here is the example. This is what we call if else ladder. If test expression 1 statement else now we will check test expression 2 else again we will check if state expression 3 else, and so on. Now here it is like a dice, because if any of this statement is true, the others need not get executed, and that's why it is else if, and at the end you write only the else statement. So if this is not true, then inside that, if this is true, not true, then inside that, if this is true, not true, then inside that, and so on. So this will get executed at some point of time. If it doesn't get expression 1, 2, 3 valid, it will finally execute the else statement. Let us try and understand this particular example where we are relating the two integers using equal to, greater than, and less than signs. So include stdio.h will start the program int main int number 1 comma number 2 semicolon printf enter two integers. Now you do double entry in the single scanf statement. So slowly we are reducing the scanf statements and printf statement. In the beginning we were writing enter the first integer, then scanf, then enter the second integer, then scanf, and so on. But now we are trying to reduce the program length and understand one of the complex terms, terminologies, or longer programs, and that's why we are reading two numbers at a time. Now when you read two numbers, you have to put %d whenever you want to read, and then put ampersand number, and again comma. If you need another variable, put ampersand and whatever that variable type is. So here number 1, number 2 were integers, and that's why I use %d. You can also take %f, %c, anything in a single scanf statement. You don't have to execute the separate scanf to take out the %c and %d. You can do both in a single scanf statement also. Now the checking starts. How the checking is done? If number 1 equal to number 2, then printf result dash is number 1 comma number 2. They are equal. Then else if number 1 is greater than number 2, printf this number 1 is greater than number 2. And third, only else, because if else if and then final else will be less than. So you don't have to check. It is not equal, it is not greater than, that means it is definitely less than, and then you return 0. Here again, when you write this program, I want you to check whether C program understands -3 is bigger or -2 is bigger. Okay, and you have to tell me what happens in the negative number, which one is bigger and which one is smaller, and how this greater than sign works. Next is output. Enter two integers. Somebody has entered 12 and 23, and result was displayed that 12 was greater than 23. Next we go to the nested if else statement. So the first one was ladder if else, and now we go into the nested if else. So in the program, same thing which is greater than, less than, or equal to can also be done using nested if loops. Now let us understand what is the difference. Okay, So first thing is we took the two inputs. So first four statements or five statements are exactly the same, but now the logic changes. Just focus here. First we'll check if number one is greater than or equal to number two. Okay. So that is the first thing. Then inside that, if that statement is true, then we will check another if. So there is no else after if. So that is not a ladder. There is if after if. So whenever you see these kind of statement, you have to assume inside if we have written another if, and that's why we are also putting tab so that we know we are going in, and how many times you go in, that many times you have to come out with either else statement or without else statement. So if number one is not equal to number two, then you don't have to display the equal to sign, and that means it is definitely greater than, because I have used greater than equal to sign in the first case. And if that is not the true, then you can just print less than and then finally out. So this is kind of in some cases nested if is necessary when you want to check. For example, you want to stop the car suddenly. Okay, then you will check what is the initial speed. That will be your first if loop. Secondly, you will check how far is the next car from your car. So how much distance you have before you can stop your car. So it will decide the kind of braking. Third is again if you will check what is the tire or the braking capacity of my car. So if all these three matches, then I will take some decision. So most of the intelligent computer program will have nested ifs and if ladders. When to use if ladder and when to use nested if, everything can be done with both kind of statements. Only thing is with nested if, it becomes complex and complex, and there are chances that you miss out certain case. Whereas else if ladder, most of the times it is very easy to execute, and there you can have multiple statement in a single loop. For example, I want to say here also you have see there were two statements executed. If you have to check for a condition where A is equal to B and okay, these are the second condition, and if A is greater than B, okay, this is kind of ANDing operation. Sometimes you have to do ORing operation, and these two conditions you have to put inside if you want to write a ladder of if. And whereas in such scenarios, it is always better to use nested if instead of using this and or symbols, because that will simplify your loops. Though it will take you in and multiple if statements you might require. But whenever you see a nested if, this is the flow of ifs you will see. And whenever you see a ladder if, this is the flow. Next is we will see the output. If else statement has only one and you need not use the brackets. So this is another thing. If you don't have multiple statements to be executed after if, you may not use the bracket. So this is the equivalent code. The first code is a traditional code where we took a bracket and we put the bracket around, opening curly bracket at the top and closing curly bracket at the bottom. But if that is the only statement, you can write it like this also. I personally always put a curly bracket open close because it makes easier, life is easier. If these two codes are same, I will always prefer the top one, though the bottom one is also correct and easier to read. For a programmer, it is always easy. Let's say I want to put another condition inside this, then I have to don't have to worry about the putting the curly brackets which were not initially there. So that's why I always have a habit of putting the curly bracket. But in the exam, if somebody asks, don't get confused, this is also equivalent to this one only, and there is no printing mistake since it has only one statement. Remember this very carefully. If you have more than one statement, you have to have this curly braces, otherwise your program will not execute the next statement. Now in the programming, loop is used to carry the repeated operations. Till now, we haven't studied anything about loops. So loop is basically if you want to check for multiple things, you have to do the same operation again and again. And this repeated operations can be done with the example of loops in C programming. there are three main kinds of loops, which are for loop, while loop, and do while loop. We will learn about for loop in this particular tutorial. Then we will learn about while, and finally we will learn about do while if we have time to finish. So let's start with the first loop, which is very important. Now, with the help of for and if, you can conquer almost 99% of the C program. If you know for and if, you can have 99% of the program, you can write them. There are certain cases where switch or do while are necessary, but basically for and if combination can do 99 times the program. So let's start with the for loop. Now for loop always start with initial statement, then test expression, and then the update statement. Now statement inside the body of the loop, which is getting executed again and again and again and again. For example, a simple example of for loop can be, let's say you want to generate a Fibonacci series. So after I stop the recording, what are the programs you need to write? Firstly, whether it is a even or odd signal, okay, odd number. Secondly, you want to compare two numbers, okay, and determine which one is greater, okay. And now third thing is generation of Fibonacci series. Now those who are unfamiliar with Fibonacci series, basically it is 0 plus 1 will result in 1, then 1 plus 1 will result in 2, then 2 plus 1 will result in 3, then 2 plus 3 will result in 5, and so on. So it's the series that goes like 0, 1, 1, then 2, 3, 5, then 3 plus 5 is 8, then 8 plus 5 is 13, and so on. So this is the kind of series you need to generate, and it can go up to 100. So for that you need to use a for loop. Now, how to achieve that using a for loop? Basically, you are doing a repeated operation, that is first integer plus second integer. And every time you will see that first integer will get replaced, and then a new next integer will be entered. And then you have to repeat. The answer will be loaded as the new integer. Okay. So you have to think in this way how to write a Fibonacci series. Remember, first you have to start with two integer. Whatever is the answer, you have to update your second integer with that answer, and your first integer is then transferred. Second integer is then transferred as a first integer. Another simpler example before you do a Fibonacci series, I would like you to do an example where you generate a number which are prime numbers, okay, which are 0, something which do not have any further division possible. So 6 will not be prime number because it is divisible by 2, and which is divisible by 3 also. So any number which you cannot write something like this, and it has to be written something like 1 into that number only. That is what we call prime number. So prime number is another program which we need to do. Whether we will print, let's say if user say give me the prime numbers up to the value 1000, okay, then you should able to write a C program in which all numbers up to value 1000 can be generated in an automated fashion. Okay. So for that you have to check whether it is divisible by 2, divisible by 3, divisible by 4, up to whatever that number itself. Let's say I want to generate all the prime numbers up to 128, and I am checking whether 63 is prime number for or not. So I will start dividing 63 by 2, 3, 4, all numbers up to 63, and then I will find that if it is not getting divided by any other number than 63, then it is a prime number, and at that time I will display that value at the output. So this is about the for loop. Now for loop program, we will see how this for loop works. So initialization statement is executed only once. That is where you set the value. Then the test expression is evaluated, and if this test expression is false, then loop is terminated. However, if the text expression is true, the statements inside the for loops will executed again and again and again and again. Okay, and this process goes on until your text expression becomes false. So let's see what is the example we have in the for loop. Before that, we will see the flow chart. Now flowchart typically looks like this. The first is we haven't learned the basic about the flowchart, so I will just brief you here. Whenever you start a flowchart, you have to put a start block. Then whenever you are taking the input from the user or giving the output to the program, you have to put this particular block for input and output. Whenever you are doing some standard operation in the computer, you have to use the rectangles. Now, whenever you are using some decision making, you have to say diamond, and one of the diamond arm should be yes, and other arm should be no. And then again, when you end the program, you have to use and most of these are required blocks. Other than that, there are multiple other blocks also, but for you these many blocks are sufficient. Start and end block or start and stop block, sometimes they are also called as stop, will be kind of straight lines, and then there are ovals connecting to it. Then all the non-rectangular but parallelograms are used for your input and output statements, and all the regular expressions which are getting executed are given by rectangular blocks, and all the if kind of statements or condition checking statement are given into the diagonal. So this is about the flowchart. Now let us understand how the loop works or for loop works. First, it will initialize the expression, then it will test the expression. If the expression is true, it will execute the loop body, then update statement will be executed, and again the next test will be carried out. If you put this update statement impossible, then you generate something called as infinity loop. And this is what is a virus. The first virus was created by not putting the correct update statement. That means your computer will keep on this thing forever until you remove the power supply. So this is kind of for loop. I'm sure you will write a infinite statement for loop soon somewhere, where you put something like expression which you think will get executed sometimes, but practically it will not get executed, and you will end up running the program continuously. Now, in old days, people used to be very careful about not to put infinite loops anywhere, because they used to restart all the machine, and whatever work they are doing in the background gets lost. But nowadays, there are separate cores running, so only one core which you can shut down using a task manager. It is not a big deal now. So writing an infinity loop is not so dangerous as it was in 1995. Now, if that statement is false, you will come out of this for loop. Let's see one example for loop. Now you have to see this program will generate or print a number starting from 1 to 10 using a C program. So first hash include stdio.h, and we have other four standard statements. Then int main curly bracket open int I for I equal to 1, I less than 11, I plus plus or plus plus I. Now these are the two different statements. If you write I plus plus, it will first check for the value of I and then do the addition. And if you do plus plus I, it will first increment and then check for the number. Then you say printf %d comma I and return 0. So this is the output you will see. And here you have to do one thing before putting plus plus sign before I, and then try executing the same loop but putting plus plus sign after the I, and you have to tell me what is the difference between the two outputs. Now, how this particular program works is I is initiated to 1. The text expression I less than 11 is evaluated. Since 1 is less than 11, it is true, and hence the body of for loop will be executed, and it will print the value 1 as a value of I on screen. Then update statement plus plus I is executed, which will tell the value of I is now 2, and again the expression is evaluated. Now here you will see that it has appeared that whether it was I equal to I plus 1 or plus plus I or I plus plus, everything is getting executed after this text expression fails. So you have to see whether I plus plus or I equal to I plus 1 or I plus plus, whether these three make any difference to your output or not. Next is the value of I will be 2. Again, the test expression is evaluated and the loop body will print 2. And again, it will increment the value by 1, but still I less than 11. So this process continues till I becomes 11. As soon as I becomes 11, I less than 11 becomes false and for loop terminates. Second example is program to calculate the sum of first n natural numbers which are positive integers up to n. Okay. Let's say I want all the numbers sum up to 5, number 5. So what is that sum? So similarly, it's a simple program. So first thing we have to do is include stdio.h int main and then int num comma count comma sum equal to 0. So three variables are declared. Enter a positive number. Only one is taken from the user. Okay. Next, let's see if count equal to 1. So we start with 1. If count is less than equal to num plus count, then sum equal to sum plus count. Okay, so it will add that particular number which is initialized as 1. So initially it will be 1 plus 1 loaded into the sum. Now initial value of sum will be 0. So 0 plus 1, 1 will get stored into this. Then finally print sum equal to and then comma. So whatever is the number that you enter, it will go up to that number and then it will stop. Now imagine if user enters this num to be -3, then this count is greater than equal to -3 is never possible. And that means this will go into the infinite loop and your program will never end or stop. Okay, so you have to make sure that you enter a positive number greater than 1 to run this program. And the correct answer for this depends on what is the entry by user. So if user enters 10, the first 9 number sum will be 55. So the value entered by the user is stored into the variable num. Suppose he enters the value of 10, the count is initialized and test expression is evaluated. Since the text expression is count greater than equal to num, which is less than 10, then the statement is true and body of the for loop is executed and sum will happen. So 0 plus 1 is equal to 1. Then update statement will do count equal to count plus plus. So now the count will become 2. Again, text expression is evaluated. Since 2 is also less than 10, it will again continue because the statement is true, and again addition will happen and this will continue. So this time the sum was initially 1 and the count was 2, so addition become 3. Now here you got this program is very similar to your Fibonacci requirement. So this program you can refer to generate a Fibonacci series. Now this this term goes on till your count reaches 11, and whenever your count reaches 11, the condition will get false and your for loop is terminated. So I will stop recording now and we will start coding. If you have any doubts, you can ask me when I rejoin the meeting.